Hey everyone! So welcome to my stream. This is actually episode 30, which is pretty crazy. Yeah, that means I've been streaming for, what is that, like, if it's approximately about, say, 2.5 to 3 hours per stream, that's a good, like 70 something hours I've been streaming this. That's pretty cool. So if you caught my last stream, it was pretty fun. We started working on improving the rendering of the emulator. So this is what the emulator looks like right now. So you can see like the lines are rendering, and this looks okay. I'll bring in the middle here. This looks alright, but there's a lot that's wrong with this. And I'll show you when I actually start playing and moving the ship around. So you can actually see it here. The way there's this kind of like weird flashy double image thing going on. And same thing when I move my ship. There's this kind of strange like shadow on my ship, but it's not quite smooth or anything like that. It's very jumpy. And the reason for that is simple. In fact, if I just break here, you can see like there's a double image of the ship there. I'll try and show that again. Let me just die one more time. Or like this. Here we go. Like all these renders here, this just looks totally wrong. And the reason why that happens is mainly because of what I'm doing here. In my render loop, I have this hack where I'm like drawing lines, and then at this rate of 50 Hertz, at approximately 50 Hertz, I go and I just clear the lines on the screen. And the problem with this is that that's not at all how a CRT, a vector-based CRT works, right? The way it works is you have this beam, and this beam turns on and draws vectors on the screen, which excites the phosphors on screen, and then those phosphors just decay. They have a natural decay back to black. And so what I'm doing here is I'm just, I don't have that because I'm just doing very simple OpenGL begin. Here I've like basically most of the time we're inside here where we're just doing a immediate mode GL begin on lines and just drawing the 2 vertices per line. And all of these are just stuffed into this this array of lines. And yeah, like basically what I do is at approximately 50 Hertz, I go and I'm drawing those lines all the time, and then I just clear the full screen, and then we start drawing the next batch. And this is completely disconnected, first of all, from even the very concept of a frame in the terms of the Vectrex. So like this could happen anywhere in the middle of a so-called frame, and there is no real frame, but there's kind of like a pseudo concept of a frame on the Vectrex. It's when the program decides to say wait for the beam to be recentered and all that. But this is completely disconnected, and on top of that, with varying frame rates, we can have some measure of error in there. So that's where we get sometimes the overdraw that we saw of the ship having like some multiple lines drawn here. So there's all kinds of things that are just wrong about this. So last stream, I went and started looking at. I had this idea for how to do this using a texture, and I did some drawings here, and I got this tutorial from opengltutorial.org on render to texture. It's all open source and available here on GitHub. So I downloaded that and started modifying it to make it do what I wanted. And what we ended up with is this was kind of what I was looking for, was a concept of having a 3-pass system where in pass 1 we just do a normal render of our lines to a texture. In pass 2 we take that texture and we darken it, and this is the place where we simulate the kind of phosphors going dark on the entire screen, right? So it's like a screen space darken that we do, and there's a shader for that, a fragment shader that we'll take a look at. And then finally we take that second pass output, which is another texture, and we just render it to to the screen frame buffer, and that's what we end up seeing. And the darken texture shader is actually really simple. There's a lot of commented out code here, and what I ended up with last week, I have a bit of extra code here that I worked on in between the streams, but what we ended on was basically this line here, where we say that the output color is us sampling the input texture, which is, if you just imagine the line, the texture full of lines and all that we know we're rendering vectors to, and we subtract from it the frame time, and we have some speed scale here, but we take the frame time, so the delta time that's being passed in, which we use basically to get like a time-based fade to black, and we make sure that we clamp this so that it stops at 0, 0, 0. We don't go into the negatives. So that brings us to in this case, it's a linear interpolation towards 0 that this gives us. And also, crucially, the output texture from the darken is the input texture of the first pass on the next frame. That's very important because we want to be able to keep drawing into this texture, and as we fade it down, the old lines that we drew in it continue to fade to black, right? So one of the things that's really important is we're basically swapping textures from pass 1 and pass 2. So the output of pass 2 becomes the input of pass 1 on the next frame, and we purposely do not clear the buffer here because we want to keep what's there. So that gives an effect. So this is what this looks like right now. If I just show it to you here. Okay, here we go. So this is the effect right here, right? So this is just like these two lines I'm drawing, and I'm using the mouse to move it around the screen, and you can see that there's this kind of fade out effect. Now the thing with this effect that we see right now is because it's a linear interpolation, you can see that it's very linear in the way it moves. Like this. If I move slowly, it does this. If I move quickly, you see lots of lines, and it's really like very much like almost like a slinky. It just kind of. And I mean, there's a bit of a speed up right now, but if I slow it down, it's really obvious. Go to the speed scale here. Right. If I just tweak this value for the speed scale, let's say I just put 1 and move, whoops. Here we go. Just trying to get my mouse. Hello. Oh, here we go. So here we really see the effect, and you can see that it's very linear, which is cool, and it's interesting. But in fact, the kind of fall off that we get for the way the phosphors fall off to 0 isn't really a linear thing. It's more of a, it's the kind of curve that you imagine is that it falls off quickly and then slowly fades out. So basically that's like a damped equation, and so that's what I messed around with since last stream. Is where are we here? Oh, wrong file. Okay, here we go. So what I did is I wrote this little integrate damped function that's basically using a power, an exponential function on some rate you give it and the delta time. So you take some rate and take the power to the delta time, and that produces a ratio. I mean, I have a couple here, 1 minus the rate to make it a bit easier to use, and 1 minus the ratio to give me more of the range where I'm looking for, and then I basically do a linear interpolation of the current value to a target value using this ratio. And this kind of damped equation, what it does is that it brings you towards a target really quickly, and then as you get closer and closer to the target, it slows down. And so that gives a kind of a damped approach we're talking about. Something like, if I were to draw it, something like this, and right, let's say the current is here, and then the target is here, and we're starting here. Instead of it being a linear equation that just goes up in a straight line, it'll be something more like, it'll go up really, really quickly. That's not quite right. It'll go up really, really quickly, and then start to fall off. Something like that, and eventually start approaching this one here. So that's more of a damped, and of course there's ways to modify the shape of this curve based on the values that we feed here, for especially based on the rate here. And so, instead of using the linear one, if we instead we go and we use this damped version, which looks like this. So we sample the current value from the texture. The target in our case is we want to get to 0. So I mean, I drew it upwards, but in reality we're going from a color value that's up here and we're bringing it down towards 0. And so I have this rate 99. So 0.99 means, you can think of it like this. It means we want to achieve 99% of the target within 1 second. So that's the kind of curve that this is what controls the shape of the curve. And finally, we compute the color by saying do this integration of this damped integration from the current to the target at this rate using input frame time. And I use this darkened speed scale to allow us to control how fast we really want it to go from the outside. So, and yeah, this is just a uniform that I added. So with this guy, it looks kind of like this. Okay, so if I go quickly, the difference here is that even if I move very quickly, we don't see this long trail as we did before, and that's because of the fact that it's approaching the target much more quickly initially, even for large movements. And so this is a lot closer to probably what a CRT does. And you know, we can control the speed here. So like if we bring the speed down to, let's say, 1 instead of 5, and try and bring it back. There we go, here it is. So you can see here it's not quite like the linear one. It's similar, but it's not quite the same. So pretty cool, right? So anyway, my goal is to take this now, this code which, you know, we hacked together, and to bring it into the other emulator. Oh, and one other thing I wanted to mention, it's kind of an interesting problem. So this was all working on stream, and then when I was off stream, I tried it again, and it wasn't quite working. And what was happening is that it was fading down and then reaching some value and not going below that. And I don't know if I can actually reproduce it, but it basically, let me see, I'll try to reproduce it and we'll see if we get the same effect. And I mean, the fix is right here. I'm swapping these two lines, so that's the actual fix, but I'm going to explain it. Let me just see if I can reproduce the bug. So we're not going to see it now because we're scaling up to 5, but if we don't scale, let's see if it still happens. Yeah, so it is happening. Okay, I'm going to just bring my, whenever I change screens. Okay, so what you're going to notice, I mean, maybe you won't notice it on your screen, but you'll notice here that if you pay close attention to the background, we're not quite getting to black. We're getting to some kind of gray value. It's not completely fading to black here. To make this really obvious, clear color. So if I, instead of this, I set a really obvious clear color, like, let's say we clear to red. Let's see what that looks like. Okay, so right now we're okay. Now if we go once again and put a breakpoint here, and basically we don't scale anymore to 5 times, we go to 1. Okay, I guess red is not really showing, but in fact I think we can exaggerate this. If we make our speed scale even smaller, 0.1, let's say, let's see what that looks like. Okay, there we go. This is going to show the problem. So what's going on here? This is not working anymore. And so the issue here is actually something I didn't know. I ended up speaking about it with one of my coworkers who's he's a graphics programmer, where I work, and he I explained to my problem I was having to him, and I told him I was passing in a delta time, and I'm using that to bring the buffer down, and then he realized right away what it was because he had faced this before. So basically, it has to do with this frame time value here, and by default, when we created our texture buffers, we created them as RGB buffers where it's 1 byte per buffer, right? So basically what that means is that the resolution of red, green, and blue is 1 over 256 in terms of bringing it into the, into float, because everything in the shader is going to be, ratios of 0 to 1. You don't deal with the actual values, so everything gets normalized to 0 to 1 range. But if you have, let's say, 1 byte per color channel, that's 256 possible values, and so 1 divided by 256 means that you have effectively a resolution of 0.00390625. You have this in terms of increments 256 times. So from 0 to 1, you have this kind of resolution, right? And this is a quantization basically of the space into 256 parts. And the problem is that my delta time, can be so small, or even if it's not so small, but if it is smaller than this value, it's as though it's not there. And if I'm taking a value and I'm subtracting something really small, smaller than this or anything, basically anything that's smaller than this value is just chopped off. It's just lost, right? It's a quantization problem. And that's what we're seeing, is that I'm trying to darken, but I can't quite get to 0 because the values I'm feeding it are so small that they are getting completely chopped off. There's an error. Anything under this is an error. There's an error value to the subtraction that we're losing. It's just total loss. And interestingly, I was able to fix it by introducing a thread sleep, right? Like a sleep for whatever time, say 0.5 milliseconds, and suddenly it worked because the delta times that I was passing in were larger, and it was somewhat working better because I was feeding in large enough values to bring it down to 0, despite the fact that there was still some error. Anyway, the real fix to this problem is not to do this kind of hacky wait in a loop and all that, but in fact to change our buffers to use 32-bit floating point buffers. So that's what you see here, right? So when we create our textures, we create it and we say we want to use an RGB 32 float, 32F buffer, where each channel is a float. So that basically gives us the full resolution, like the full 32-bit float resolution that we want. And that matches the float resolution of the time delta time we're passing in, and so there's absolutely no loss, no error, and it all works, right? And then I was wondering if this could be a problem, and with video cards supporting it, and apparently float buffers like this have been supported for quite a while, so it's not something to be too concerned about. So yeah, and that was rather interesting just to see. So yeah, so there we go. So that's pretty cool. And so tonight I'm gonna work on basically bringing this code into Vectrexy. So I'm not quite sure yet how I want to go about doing that. I was kind of thinking a little bit about it the past couple days. So let me just take a look at my code structure again. Right now I just have all my source in one source folder. I was considering whether I should start separating things into directories, because I'm going to be breaking down this OpenGL stuff into multiple files most likely. But I'm going to start with just one file, or one pairing of files. So I have an SDL engine. Right now the OpenGL stuff that I do is in here, and I want to move that out because we're going to be iterating on this stuff, and all this, initGL and anything that starts with GL really shouldn't be in here. So set viewport, the clear, so all the display stuff shouldn't be really in here. So let's get that out of here. So this is the SDL engine, and I guess we'll call it maybe the GL renderer. Or maybe the GL display, because I was just thinking about the types. You know, we have here an SDL engine with an iEngine client, but we expose up here a display. And most likely what I want to do here is actually, do I want to do that? No, I think we'll go for open or GL renderer, and we'll work from there. We'll see how that goes. So I'll add that in source. Okay, I'm gonna call it render. I'm not sure if it's a renderer just yet. So it's just gonna be a bunch of functions. We'll see. Just bear with me. I'm gonna just be moving stuff around here. Yeah, I don't know if this needs to be a separate function. Yeah, this may not work. I may actually need some kind of update viewport or something here, or set viewport being exposed now that I think about it. Because when the screen is resized, we might want to set that. I see. These are SDL GL functions. That's interesting. Before window creation. Okay, so it's kind of important that this gets called before. Interesting. You know what, in that case, I'm going to leave this in SDL side of things, even though it's not super clean. Whoops. In a sense that there's some OpenGL stuff. This is really the SDL OpenGL portion of it. We do an SDL init here, then we say set OpenGL version, and there is some more GL stuff here, like window OpenGL here. So when we know that this SDL engine is expecting a GL render, so we set this stuff up here, and that's good. There's even a GL context here and everything. So yeah, it's rather important that this get done in the right order and in the right place. So GL shade model. So yeah, we want to include GL.h. Is it really small letters? Okay, so this is also gl.h. Okay, so there's this whole SDL OpenGL business here. Seems like it just contains a bunch of helpers. This guy right here. Even though these functions are technically defined in gl.h, I'm not quite sure what the deal is here. That's problems with Windows API maybe? Let's see. Yeah, exactly. Oh, that's interesting. So, set viewport here. I was using the screen width here. Is that wrong? That I was doing that? Yeah. We actually want the Vectrex dimensions in there. Interesting. So there's like window width and screen size, okay. So the projection matrix is set in terms of the window size, but the okay, this is kind of strange. Sorry, the viewport is set up this way, but then the projection matrix is set up in terms of the screen size, which is more like the logical game space. Turn true. No, here you have to pass the window, so never mind that. So initialize shutdown, set viewport. Is there anything else we need to move in there? Yes, we're gonna have to move the display. Okay, I'll leave it the declaration here. We'll implement it in the render here. Okay, so STL engine builds, NGL render builds, so that's good. I suspect that I still need this header here. What am I calling? Oh yes, there's a GL load identity. Why? Right, we wanted to have the model view matrix reset to identity here when we call render. So that's more of a property of the display, if anything. Hey Moosey boy, you ask why am I using the fixed pipeline? This was temporary. I guess you missed the beginning of the stream and also maybe last stream, but I quickly hacked in this fixed pipeline just to get some lines up on screen, and since last stream started working on a version that uses proper shaders. And what I'm working on this stream is replacing this fixed function pipeline and this crappy shader, like this non-shader code, with the code that I worked on in this tutorial that I modified last week. So there won't be any more fixed function pipelines soon. Yeah, so where do I want this? I guess I'll just, for now, do something like Moosey Boy says, cool, I'm just moving from Java to C++ and I'm finding the journey very interesting. So far I love and hate C++ at the same time. I can understand that. I mean, I've been using C++ for a very long time. So, I'm very comfortable with it, and I've kind of kept up to date with all the updates, 11, 14, 17. But at the same time, I do help a lot of people who are just learning C++ at work, and so I can see, the challenges, and it's a language with a lot of warts. It's got a long history, right? It's like 40 years old, and it shows, right? It's got a lot of weird stuff to it, a lot of a lot of rituals that you have to follow to make sure things work. Sometimes you don't understand these rituals, you know, people just tell you, just always do this, and that's because that's the path of least resistance when it comes to C++. But, you know, it is a language that's improving, and hopefully in a few more years, there'll be this nice subset of the language. I mean, there already is a nice subset of the language that's easier to use, but it's still not 100% there. Alright, so still unsure about whether I want to go with this kind of namespace approach or not. There's a lot of things that I'm mulling over in here. Thinking about how, you know, ultimately for cross-platform stuff, what I'm thinking is like eventually I'll probably have some file, you know, like, you know, render or renderer.h, I don't know, and I imagine something like using render equals to GL render, maybe, you know, and like it'll be like, if we're using the GL renderer, the GL render stuff, this is what we're going to do. Else elif, you know, something else, then render will be something else, and it'll be similar for SDL engine, where it'll just be like the engine, and then this way we can kind of, you know, have on different platforms where we don't want to use SDL or can't use it, we can do that. Or if we don't want to use OpenGL to do the rendering, that's fine as well. So that's sort of what I'm thinking about. But I don't like to over-engineer things until I actually need them. So it's kind of like I'm just thinking about the future and setting up the code for that kind of thing. So I think this is good. One thing I'm not a super huge fan of right now is how I have this display class declared an engine client along with input, but that the actual implementations, well, input is all implemented inline here, so no big deal. But display here, the implementation is now right now in GL render, so it's a bit unclean. But at the same time, this is where the core of the display stuff goes. So again, there's different ways to go about this. Yeah. I'm not going to concern myself too much with that just yet. Does this build? So Moosey Boy asks, is using render equals GL render the same as define renderer GL render? It's not exactly the same. You can get something close to that using the preprocessor, but it's not quite the same. So you know, the using declaration is something that the compiler is aware of. It's not something that happens before the compiler runs. So define is basically something that the preprocessor does, and it's more of a search and replace, right? Whereas the using thing is, for example, if you do a using declaration inside of a namespace, it'll bring that name only inside that namespace. So that's one big difference, right? Whereas with the macros, you know, define, it doesn't care about where namespaces are because it's just a search and replace. So it'll leak out of namespaces. So I don't know if I lost you there, but that's it's a pretty big difference. You know, like for example, if you had, let's say, namespace foo, and you know, in here you said using render equals to, you know, GL render, then it's only within the namespace of foo here that I can use the name render. On the other hand, you know, like and like say it was render initialize or something, you know, I had a function in here. Oops. That's fine, right? But if I had another function outside of the namespace and tried to do render something in here, this would not work. This would not compile. On the other hand, if I try to do this with a define, like that, this would compile, but so would this. You know, so it basically leaked out because the preprocessor sees this line and says, oh, okay, everywhere I see render, this token, I'm going to replace it with GL render. So it sees it here, and it sees it here, and it replaces it. To kind of get the same type of thing, you'd have to do like an undef render here. And then it would no longer leak out. But you see that's the main difference there is that this is seen by the compiler, and so it follows scoping rules defined by the language, whereas this is really just, you know, preprocessor take token pasting type of stuff. So does that make some sense? Okay, so this actually looks like it built. Moosey Boy says, right, noted, many thanks. Didn't even know you could undef stuff. Yeah, in general there, you know, if you're doing C++, because you said C++, right? And you're coming from Java, like the preprocessor is something we try to avoid as much as possible. I mean, you can't completely avoid it, really. I use it, of course, for certain things where I have to, but in general, we try to avoid it. So what I mean is that if there's an alternative to using the preprocessor in the language itself, we will use that. You know, in C++, we'll tend to use the language features. So right, like for a good example of that is, you know, don't declare constants with a macro. You know, don't do like, you know, my value 15. Instead, do, you know, const int my value is equal to 15, right? This, the compiler sees it, and you're putting a type here, and you're gonna get type safety. So that's the kind of thing, you know. In C, on the other hand, you'll see macro usage much more often, partly because in C you don't have the same facilities as you do in C++. Less for, let's say, for constants, because I believe you can do this no problem in C, but more for templates, you know, or for inline functions. But templates is a good example. C++ has templates, and so you can actually declare templates in the language, fully supported and understood by the compiler. And you don't have that in C, so if you want to write stuff that can apply to any type, the only real way to do that is with macros in C. So you'll notice like those kinds of differences. But in C++, we really try not to use it as much as possible. Okay, so I'm gonna commit this. Just go look again at SDL engine, see if it's clean. So we don't need this. I'm trying to remember what this base thing was about. I have this to do remove this question mark. Let's see if we really need it. Okay, why isn't my num lock was pressed. So what have you been doing in Java? It looks like I don't really need base.h. What about string helpers? What am I doing with strings in here? Oh yeah. Oh yeah, I got this options stuff in here. That's why. Because I wanted to move this option stuff out at some point. Well, you know what? Let's just do this. Clean this up a bit. One thing I wanted to do here, just looking at this set OpenGL version, so we're going to want GL to tell us that. Let's do it like this. We'll use a tuple. We'll say get major minor version this way. So Moosey Boy says that he's a web developer by profession, just making small game experiments in GL for fun. Working on a voxel engine at the moment. Implemented SSAO yesterday. Disappointed with the performance hit. And this is in C++, OpenGL, using shaders for your screen space. Once again, it's I forgot what that acronym stands for. I know what it is, but it's a SSAO. Ambient occlusion. Okay, yeah. And your performance isn't good? 330 core, C++. And is it like an implementation problem, or like is it like a GPU problem? What is it you think that is at fault for this? Or is it just that it's a slow algorithm to implement in general? I cannot wait till I can do this here. I want to be able to do major minor. Is this not yet supported, or is it supported? Oh yeah, it is supported. Awesome. Okay. See this here? This is C++ 17. Structured bindings. This allows me to take a tuple and unpack it into variables. In this case, there'll be ints. I could see int references here. Got deduced based on the type of the tuple here. So then I can say major minor, and then we're golden here. Moosey Boy says, when the mesh is far away, it's okay, but when the triangles get closer to the camera, it slows down because of some of the caching problems. Looking up pixels in a texture closer to the current fragment is faster than pixels that are further away, apparently. Looking at pixels in a texture closer to the current fragment is faster than pixels that are further away. Oh, okay. You mean like relatively closer in screen space? Oh, so you even have a link. SSAO is slow and geometry is near camera. Where the texture sample does not matter to performance as long as they are not random noise causing anisotropic filtering to peak at maximum samples. So this guy's saying it doesn't seem to matter how far away it is, right? Where the texture sample does not matter to performance as long as they are not random noise causing anisotropic filtering to peak at maximum samples. So he's saying maybe the texture is too high resolution and you want to use a low res one and scale up type of thing. This is definitely about cache misses. Texture caches work spatially, so if samples are scattered on screen, you get bad performance. Camera space based sampling means that sample at 1 meter away can be 1,000 texels away when current samples in your camera. There is really clever way to solve this by using depth maps. Then performance is constant no matter how close or far objects are. That's interesting. Interesting, really interesting. So the reason why I moved the minor version into the GL render is because the next change will be to make it 3.3. I don't know if there's a way for me to specify core. I wonder if this is good enough for that. So Moosey Boy says, yeah, there's room for improvement for my shader, but it seems in general SSAO is slower, closer by. Right. You know what you do? Just set the near clip plane to be far away, and you're all good. So Moosey Boy asks, on the auto subject, he says he often finds himself lazy and just using auto everywhere. And when do you recommend to use auto, and when should I use normal type definitions? That is a great question, and it's a contentious one actually. Some people, like Herb Sutter, have written articles like. So Herb Sutter is this guy. He works at Microsoft, and he's like the head of the C++ standards committee. And he wrote this article called "Almost Always Auto: The AAA Style." And you know, it's a really interesting read, and he talks about using auto pretty much everywhere and why you should use it everywhere. But this is a very contentious opinion. A lot of people don't agree with that. Google has a standard that they, for C++, and they talk about auto. It's in here somewhere. Auto, yeah. And what they say pretty much matches what I kind of go for. Here. So they say use auto to avoid type names that are noisy, obvious, or unimportant. Cases where the type doesn't aid in clarity for the reader, continue to use manifest type declarations when it helps readability. So, and they talk about pros and cons. And basically what they're saying is that it's all about increasing readability. That's exactly what I feel as well. And so they say, for example, it's encouraged for things like iterators and other long, cluttery type names, particularly when the type is clear from the context. So calls to find, begin, or end, for instance. So some of this is like convention, right? Like we know that the STL algorithms. Oh, thanks for the follow, Moosey Boy. So we know that the STL algorithms return iterators when you call begin and find. And so there's no reason to spell out the iterator type. So we just use auto in those cases. When the type is clear from the context, so like in the same expression or within a few lines, you can tell what the type is. So that's really important. Initialization of a pointer. So like for example, oftentimes you'll find yourself, if you're not using auto, having to retype the type name twice on the same line. Like you want to create a unique pointer, so you say make unique, and you pass the type you want to create in the template parameter to make unique, and that's the same type you spell out when you type out the unique pointer of that type. So when you have the type name twice on the same line, that's a great place to just use auto for instead of the whole type name, because it's there. You can tell just by reading the line what the type is. And basically try to avoid it when you cannot tell what the type is from the context, you know? So that's like a general rule of thumb. And here, on the other hand, for destructuring, you know, you look at this line and you're like, well, I can't really tell what the type is, you know what I mean? So does this break the rule a little bit? But the thing is, for destructuring, you have no choice but to put auto here. And so there's a bit of a, here the idea is this function, get major minor versions, should be telling us this function returns a major and a minor version. We can kind of assume those are int values, you know what I mean? Maybe. I think it's pretty clear. But if I had a function that returned like a tuple of all kinds of different values, you know, like of different types, I mean, floats, bools, and strings, and, you know, probably I wouldn't do this. And in fact, I probably wouldn't use a tuple in that case. I'd use a struct and name each field or something. So it's really like there's a bit of a gray area in there, but in general, I use auto when I can tell what the types are, or I don't care what the types are. That's sort of the general rule of thumb for me. But it's not always, you know, almost always auto. So Moosey Boy says, sorry if I'm asking too many questions. You're now my C++ teacher. Oh man, it's no problem. I love teaching C++ stuff, so it's really no big deal. So let's see now. What does this look like? Why is it complaining here? Yeah, this is not a real thing. So why do I use tuple instead of pair? Tuple is just more general, you know? I could use pair in this case. I don't like so much the pair dot first, pair dot second, you know? So, and in this case, though, it wouldn't matter because I'm using structured bindings anyway, so I'm destructuring it, and in that case, whether it's a pair or a tuple doesn't really matter, right? But, you know, maybe one day it will be major minor patch, and suddenly I'll have a third value in there. It's not the case for OpenGL, but, you know, a version could be made up of multiple parts. Although I did say major minor in my function name. I could just say GL version and that would be fine as well. I'll leave it like this though, because I think it's more clear in the context of OpenGL. But really it is not a strong reason for using tuple, other than the fact that I just prefer, I don't like pair very much. I find like, you know, naming the fields first and second is just strange and not that useful. So, I don't know. Another reason is because pair is not declared in a header called pair. You know? Where is pair declared again? In utility. You know, whereas tuple is defined in tuple, the tuple file. So, I don't know, feels like it's utility probably just brings in a whole bunch of stuff I don't need in my header file. Probably doesn't make any difference, but there you have it. Okay, so this build, let me get this committed now. Looks clean. So move OpenGL code into GL render to separate files. There we go. So that's step one. Yeah, I'm not getting my files in here. Just rerun cmake and reload here, and I should get my brand new files that I've added because they get discovered when I run cmake. There it is. GL render. So first things first, we want to use 3-3 here. Yeah, so once I go 3-3, I gotta go full shader, right? So that's good. So let's keep going. So I'm gonna be like stealing some functionality from this guy. So I've got a bit of work ahead of me. Yeah, this is what I was looking for, is setting the core profile. Let me just take a look again. I was starting to search for that. Didn't I search for that? STL. I thought I searched for this. Oh yeah, I was looking at that, okay. STL GL profile. Okay, so it's via set attribute. It was right here. But this is setting compatibility, where in fact we want to set core. Still just don't expect it to render. Okay. Alright. I don't know if I need to set the sampling stuff. I'm not really using that, so should be okay. Alright, so now I need some shader functions to load and compile shaders and all that. So I'm thinking of just kind of stealing this code right here. I mean, this stuff here I should have no problem. I was looking at the license last time. It's from OpenGL tutorials here. The thing is, they don't really have a license in here, like a license file. There's like no information whatsoever about licensing. So I'm gonna assume, since it's a tutorial site, they expect us to, like, they're totally cool with people copying their code. Why do they need glue for GLUint? Oh. Wondering if STL also defines it. STL OpenGL ext. So it looks like if I include this file, yeah, this looks like it would give me what I need, so I don't need glue. Okay, that's good. Interesting. I just find it interesting how in this demo they use a vector of char for their strings. GL get program info log. What is that? Oh, this must be why. Interesting. Still odd. Is this... Right. Makes sense. It makes sense because with a string you'd have to like... You're not actually allowed to resize a string and write, you know, to it externally. So yeah, this makes perfect sense. Let's start by just grabbing this function here, going into our GL render. STL OpenGL GL ext. Moosey Boy says I'm gonna need glue anyway. SDL doesn't include definitions for modern OpenGL. Is that right? But yet, when I look at SDL OpenGL X here, it looks like it does. Am I not reading this right? I think it's more just a question of which version of SDL it thinks I'm using. You know, like, right now it's complaining about create shader, right? But it is defined here. GL create shader. So here they are using glue. So that seems to go with what you were saying. I'm curious if it's required. Still, I mean. Now that I see that the extension file, extension header seems to have that stuff. Yeah. Everything I'm reading here points me towards what you said about using glue. Yeah. Okay. In that case, I'm wondering how simple it is for me to bring in glue into my project. Ideally, I'd like to use CMake to pick it out as a dependency rather than like bring it in hard-coded, you know, copies of it into my stuff. Is there a find for glue? Find glue. Okay, so there is a find glue there. So that's good. I think what sucks is Windows. Just all this kind of stuff sucks, you know? Installing stuff like glue, I'm guessing it needs to like write to the GL core header or something like that on Windows. Let's see what do they do for Windows. Lucy Boy says, yeah, not sure for Windows. I stopped using that crap a few years ago. I mean, I'm a Windows user because I work in video games and we just use Windows for everything. So that's what I'm used to too, right? But I mean, I'm well aware of the fact that it's not a great dev environment. They're working on it, you know? They're trying to make it better. Like Microsoft has this VC package. Yeah, this is on Microsoft's GitHub. It's called VC package. I should really look into this a bit more because this probably has stuff like glue on here. And the idea is like on Linux and Mac, you can just kind of tell it to download the packages you need, and then CMake will find them in there. Anyway, for another day. Okay, so this is just a download of the source. I thought there was a distribution. It said binaries. Sucks that they're still using SourceForge. So that's the Win32 zip here. And I have to worry also about the fact that there's a shared library in there. Yeah, so the way OpenGL Tutorials did it is they actually put it into their distribution, which is not something I want to do, but they have it in their external folder here. Let me look again what they're looking for. This is find path. So it's looking for a folder with gl glue.h. And I think if we just set, okay, I see. We just need to set this guy. Okay, then if I set glue include dir with -d for CMake, then it'll find it wherever I set it. Okay, alright. That should work. Where's the zip? just dump it here. I should put required here as well, because it is required for OpenGL. So now, if we go to a command prompt, so first it should fail because it cannot find glue. I think I'm gonna have to pass a whole bunch of variables now. But let's start with this one. So -d missing glue library, really? Do I have to pass in include? Okay, maybe that's why. It does say include dir. It looks like this one is not written to work on Windows. So somebody here on one of their projects rewrote Find Glue to handle Windows, it would seem. That sucks when the version that comes with CMake doesn't do the job. See, if not glue library, I guess I could define glue library, but I shouldn't have to. Find library. Hey, Queen of Noob. How's it going? What is a Vectrex emulator? Good question. The Vectrex is a machine, it's a console, a game console that was released in 1982. Just parsing Twitch for watching some programmer. So yeah, it's this old vector-based console from 1982. Looks like this. And it's really cool. It's got like a vector-based display. See if I can show you. So you see it looks kind of like this. So I actually own one of these and, you know, played it when I was growing up. I was a kid when my uncle got me one. So it's a really interesting challenge to program an emulator for this thing. So that's what I've been working on. And right now I'm looking at implementing the rendering using shaders, and struggling with Windows and getting glue to be recognized by CMake. So BSD3, I think I can take this, right? So like I can just go in and grab the CMake thing here as is. I think. I can steal. Let's try. So I've got this version of Find Glue, so let's see if this one works. Let's see if this works. I think I can just run it again. Except I don't want this. I want to do glue root dir. This time I take off the include. Cannot find glue. Yeah, same. Ah, but it's not using the right C. Is it? Am I getting the same exact error? I might need to clear my CMake cache. So are you coding it in raw C? No, yeah. As Moosey Boy points out, it's in C++. The code kind of looks like, you know, like this. Stuff like this. So you'll see classes and member functions and all that. Alright, so what's CMake saying? I'm getting the same thing. Oh, okay, that's it. Now it's complaining about SDL2, which is fine. So let's say that's glue, and let's give it the SDL2 directory. Active SDL2, there we go. Found SDL, found OpenGL. Could not find glue. I'm doing some C++ actually, unfortunately. You don't like C++, Queen of Noob? So you and Moosey Boy are both complaining about C++ on my stream tonight. Doesn't get enough love, this language. Queen of Noob says, well, I like, but I would say C++ is becoming better. Oh yeah, it totally is becoming better. I don't know how much you keep up with the stuff, with the standards, but you were doing C++ back in the 2000s? Yeah, I mean, I started doing C++ around 98, 99. So yeah, I've seen it go through all kinds of changes. Oh, so Moosey Boy's gotta go. Thanks for hanging out, Moosey Boy, and thanks for the follow, man. Appreciate it. Okay, so what the hell is going on here? So it is using find glue. So here it's saying, okay, so line 87. So what's going on here? Could not find glue. So really the real error is up here, is could not find glue, missing glue library. And it's sort of what I was expecting, because I saw here, oh, maybe I just need to tell it to use static, because it is it a static lib that I have, or is it dynamic? Let me go take a look. I think we saw it was dynamic actually, right? Because we have here DLL, yeah, we have a DLL in here, so this should be the non-static version, unless I say static. Actually, that might be better. But I don't think that's my real problem. I think my real problem right now is where it's looking for the library. So if Win32, where is that? If Win32, hey, you know what? I lost all the tabs and stuff, so this is total garbage. Hold on. Let me actually just do save as. There. That's better. Okay. So I think that the real problem is that glue library is not being bound, and it's because when it looks for glue library name here, find library, it's looking in end program files or in the glue router lib, right in the root of the lib folder, but that's not the way this guy is set up. So if I put here, let me see if I'll just modify this and see what happens. Lib, where is it? Lib release, let's say x64. Although, am I building 132? I am building 132, so let's say 132 then. Does this work? Yeah. So that was the problem. The problem was that this CMake script, it was looking for it in the wrong place. Now technically, if I wanted this to build in 64, I'd have to pass it some flag and tell it to look for the 64-bit one first. Now let me tell it instead to use the static version because I don't want to have to copy that DLL around. That would be nice. Is it true like that? So let's go take a look at what that did in here. Yeah, that's not enough. So that means we found it, which is great. Now I need to actually make use of it. Like the way we do down here for SDL2, say include directories, I need to say also to use the ones from glue. So what does it give us again? It says once it's found, we get glue includers, libraries, definitions, and then glue found is set. We'll get the glue includers here. We get the libraries there. Do I need the definitions? Possibly. How do I add definitions again? Target, compile definitions, yeah. For Vectrexy, private, like that. So that should give me everything I need. I did not like this. 42. So I'm missing a closing paren somewhere. Yeah, here. So come back in there, reload our solution, and now we should see glue stuff set up in our dependencies. Okay, so there's the include for glue. Yeah, that's good. That's the include path. And if we go look in the linker path, there's glue. Perfect. Although it's glue 32 and not glue 32s, which means that this static libs true is not right. Is it 1, I have to say? That did not change anything. Wait. Yeah, see there's 2 here. Glue 32 and glue 32s. Yet it picked up on glue 32. on? Do I need to say on? Those are for options, right? Oh, interesting. So when I said 0, it did change something. So let's see what happened there. Still using glue 32. I know. Sorry, that's the wrong one. Not glue 32. It's pronounced the same way, but not the same library. Oh no, it is that. Yeah, there's glue 32 and glue 32. This is still the wrong one. Queen of Noob says, I see you like old school games on your GitHub repo. Well, yeah, I do. I am old school. I guess if you were coding in C++ in 2000, you might like old school games as well. Just curious, if I was to put an S here, nothing changes. Which means that we're not going down this path, but we are going down this one. Or not? Queen of Noob says, yeah. Okay, I'm getting kind of annoyed here. I hate spending so much time on like stupid build stuff. I don't want to do this. I want to work on the shader stuff, you know? And I'm just losing all my time with just dumb setup. It's always like that. What am I missing? Where is it picking this up from? I wonder, do I have it in program files or something? No, I don't have it in here. It's most definitely picking up here because we added this and it suddenly woke up and started working. And it's picking up this guy instead of this guy. Do you need two versions of the lib, debug and release? I don't, and it doesn't come with it. I'd have to build glue to get the debug version. I don't really need it. You know, if ever I need to debug glue, I'll worry about that. Right now I just want it to link against the static version. Otherwise I gotta worry about copying the DLL, which I just don't feel like doing. I mean, actually I should just see if this builds, and then we'll see if indeed it requires it, right? So like, let's say we just we comment out this new code I added, but we just try to include glue in here. I might need to pull in a name. We'll see. Included before glue. So it doesn't like that. Fatal GL included before glue. So it wants this first. Let's try and run this and see if it asks for the DLL. Okay, so it didn't ask for anything, but at the same time I'm not even really using anything from here. So I don't know if that's... Like, what do I need from here? For example, GL, here, let's do this. GL create shader. We'll just put something, just a hack in here, just to get it to, you know what, I'll put in the init. Oh no, actually this was fine. So, okay, so right there, now that we're using a function, we're getting an unresolved external, which means that the lib that we point to is not valid. Interesting. Did not expect that. Why isn't it linking against this guy? He's looking for glue create shader, which is what this is defined to, right? Yeah. And it's not finding it despite the fact that this project is set up to link against this guy. Like, I don't think this has anything to do with the fact that it's not the static version. If I just add the S here, just to see. So that actually built. Okay, we get an exception thrown here, that's fine. Interesting. So I would have thought that linking, like building against the non-static version would have at least linked and would have expected the DLL at runtime. The fact that it doesn't link at all is a bit surprising, to say the least. But now we're back to like, why isn't it fine? It's like, if I rename this just to C and run CMake again, amazing. Find library. This is nonsense. Total nonsense. Queen of Noob agrees that this is nonsense as well. Yeah, it is. It's weird, right? Because like, I even modified here to say on both paths look for glue32s, and then we say find library. We know that it's finding it in this path because if I take this out like that, the CMake will just fail. Or not? Oh man, is this one of those? This happens sometimes where you need to delete the cache for it to pick up on new environment variables like use static libs. Like if you run it once, it remembers certain paths that it found and it ignores, like it won't actually apply the same thing the next time around. So let's see if this works. Yeah, there we go. See, it was nonsense. I don't understand really the conditions under which I have to delete the CMake cache, but it's not the first time it happens where I try to mess around with the flags that I pass to CMake, but if I've already run it once and I try to add flags or change flags like this, it doesn't care and it's silent about it. It just remembers what it has in its cache and that's that. And I'm sure someone who knows CMake a bit more than I do would be able to explain it to me, but it just seems a bit nuts to me. Like shouldn't it check in its cache that the command line options that I'm passing haven't changed before using its cached values? I don't know. Alright, so this is good. I want to just remember that I did it this way. I'm going to go put it in my README. I was looking at that before and I realized I did not have these steps in my README. So Queen of Noob pastes something I suppose you found online. CMake will not alter an existing entry in the cache file itself. If your CMake lists file changed significantly, you will need to remove the relevant entries from the cache. Sure, you know, that's fine, right? But I added a new flag that I had not used yet, and it didn't like it, so anyway. Okay. What are you gonna do? Real programmers don't write README. I do it for myself, man. You know, I forget what I'm doing, so. All right. Get line is in string, is it? Or utility or something? iStream or IOStream? No? Not the right one? No, that's not the right one. Oh, this is the one. It is from string, okay. Alright, so vector, so yeah, I guess let's get this to compile. So Queen of Noob asks, so I'm working as C++ dev in which field? I work in game development. I work at a company called Behavior. We're a contractor and also make our own games. Yeah, it's pretty cool. You love how the indie market emerged? Yeah. Yeah, it's pretty amazing. I follow a whole bunch of people on Twitter. Yeah, on Twitter who are indie devs. And you probably have noticed a bunch of them stream actually on Twitch. Some really cool indie devs just showing their projects as they develop them. I find that really fun. Yeah, I'm not sure yet how I want to organize things. I'm going to make a folder called shaders here. We'll just put a couple of shaders in there and see. I'm just going to copy these. I'm going to rename everything afterwards, but this is fine for now. And I need my pass-through. Okay, so let's just see if we can load shaders at all. When we initialize here. Let's just start with the pass-through. Right, need to pass it both a vertex and a fragment shader, of course. So let's just grab this guy here. Exception thrown, 0, in Vectrex, access violation excluding location 0. So this looks like I'm probably missing something to initialize glue. Like the function pointers are null. Yeah, there we go. Init names? What do I need here? Where's the main source file? Here it is. Initialize glfw. Ah, there it is. Glue init. It also says we need to set glue experimental to true for core profile. If you say so. Alright, so now we've initialized glue, so there we go. Got two IDs. Compiling shader, linking program. Okay, cool. So we're getting closer. Alright. Now I gotta start cleaning up this stuff too. Before that, let me just push a couple things. Add dependency on glue. I'm trying to remember, did I even use, oh yeah, the standard one. I had like completely cleaned these out actually. Can I make my CMake pick up on these and show them in Visual Studio? How do you like just add regular files again to CMake's, like to show up in Visual Studio? Okay, so I can just do this. And then do is this what I want? So it seems like I can just tell it to search for stuff. Can I just give it another path here? Will that work? No, they do show up. Yeah. Just want to check if I can use client format to apply to shaders. I don't think so. Maybe I'll just use VS Code. I think VS Code might be GLSL aware. I can add something for that. I also wonder about these extensions, you know, like, do we really want vertex shader and fragment shader as extensions? Vert and frag. Shader language support for VS Code. In these screenshots, it looks like they have GLSL as extensions. Ah, there we go. Or not. Maybe not. No. Okay, close the file. So it likes vert. So we could go with that. Frag. Let's say we open this guy here. That's cool. And then it said something about formatting. Experimental requires MSCPP tools. Really? For formatting HLSL? Oh, good night, Queen of Noob. Thanks for hanging out. If you're gonna come back, I'll be streaming again in a couple nights, Wednesday night. So hopefully I'll see you then. This is a pretty nice extension. Configure if the HSL language suggestions are enabled. Is that true by default? And doc on side. So having the documentation open in a side window in the editor. Okay, so these are already true by default. So there's no configuration for formatting apparently. View, how do you see? Like, how do I make this guy insert spaces instead of tabs? Or should I? True, I could use editor config. Yeah, that makes sense. It's actually even part of VS 2017. I think I might need to install editor config for VS Code if I want to use VS Code. But if I go into Visual Studio now, all right. Okay, just lots of setup tonight. Okay, so here I'm getting the spaces that I want, but if I want to use VS Code, I'm going to have to install editor config. And there we're getting the right thing. Okay. That's good. Interesting. Edit. Advanced. No. Oh man, what the hell? Oh, that was terrible. All open documents. Stupid. All right. Why doesn't it realize that I just changed this file on the outside? Or did I not? Is that why? Oh, it's the one file I didn't change. Okay. There we go. Okay. Okay, so I need better names for these guys. So darken texture is fine. Pass through is fine. Oh, this should probably be pass through texture. Oh no, this is just a pass through vertex shader, that's fine. Standard shading RTT. I'm trying to think what I should call these shaders. These are the ones I use to do the very first pass. Maybe we should just call this something like draw vectors. Like, I don't know if it should be the name of what it represents at a high level or what the shader does, and it feels like it should be what the shader does, but at the same time, often what the shader does is totally related to the high level of what we're trying to achieve. So in the game, or in the emulator. This definitely is not wobbly textures anymore. So what do you call a fragment shader that just renders a texture? Okay, let's just go with this for now. Thinking about what the minimum amount of work I need to do just to get something on screen. Just want to see if it's actually going to work. What the hell? Okay. All right, it's just a program ID we get. Alright, so this is eventually I guess I'll put it now. I could also name these passes, but anyway, darken, texture. Hey BD, how's it going? You're catching me close to when I'm gonna be quitting. Working on moving shader stuff that I worked on last stream into my engine. Into the emulator, I should say. Tired, stuck on a dilemma. I'm okay. Starting to get tired actually. Been at this for about 3 hours or so. And I struggled earlier with some stupid CMake stuff. That's always fun. You know what? I think I'm gonna call it a night. I'm looking at the time and it's late. I'll just pick this up where I'm at. I'll just pick this up same place on Wednesday. So I'm in the process here of just moving in this code. We got the ability to load the shaders. We're loading all 6 shaders or whatever, 5 shaders I guess it is. Yeah. So that's working. So that next step is to start actually creating our objects, you know, the frame buffer objects, and basically passing in the, like actually implementing the different passes when we draw here. Yeah. And passing in all the uniforms and basically bringing in that code. So should be good. So yeah. So ABD, I know you just joined, but I guess I'll catch you on Wednesday night if you're there. So yeah, thanks for watching guys, and I'll see you soon.